Hello student, good morning. I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss differential extraction. Differential extraction. Last class I have discussed crystallization, sublimation and distillation. Three things of purification I have discussed. Sublimation, crystallization and distillation. Now other methods of purification I am going to discuss. Then today I am going to discuss differential extraction. When an organic compound is present in an aqueous medium, aqueous means water. When an organic compound is present in an aqueous medium, it is separated by shaking it with an organic solvent. They have to shake with organic solvent in which it is more soluble than in water. You have to dissolve that compound in an appropriate organic solvent in which it will be more soluble than water. The organic solvent and the aqueous solution should be immiscible. Immiscible means it should not mix. Immiscible with each other so that they form two different layers, because both will not mix. Hence it will form two layers, but compound will dissolve in organic solvent. Okay, compound will dissolve in organic solvent, but both aqueous, we have taken aqueous solution, then that water and organic solvent both will not mix. Hence a layer will be formed. Then layers are formed which can be separated by separating funnel. This after mixing aqueous solution in organic solvent, then what will happen? The organic solvent and the aqueous solution, if we will mix, then layer will be formed. A distinct layers will be formed which can be separated by separating funnel or separatory funnel. The organic solvent is later removed by distillation. You have separated organic liquid. In that organic liquid, compound is present, pure compound is present. The organic solvent is later removed by distillation or by evaporation to get back the compound. You will get the pure compound. Differential extraction is carried out in a separatory funnel. I will send this separately funnel. I will just, it's a diagram I will send. Then here I told you that if how to separate pure organic compound from impure. If the organic compound is less soluble in the organic solvent, then what will you do? Then in that situation, a very large quantity of solvent would be required to extract even a very small quantity of the compound. If it is present there, then to remove that compound, large quantity of solvent would be required to extract even a very small quantity of the compound. The technique of continuous extraction is employed in such cases where a small quantity is now remaining and you want that quantity also, or suppose only a very important compound is there, that is you have separated, then how will you that a small quantity you will remove? Then continuous extraction is implied. What I told you, large quantity of solvent is required. In this technique, same solvent is repeatedly used for extraction of the compound. This I have told about the extraction. Now I am going to tell a new technique to remove the you can say impurity, or you can say how will you get pure organic compound. That is that technique, that process, that method is known as chromatography. Chromatography is an important technique extensively used to separate mixtures into their components. Suppose 2-3 compounds are there, but they are mixed. Then all are just like, you can say, impure only. You want to separate it. There is a mixture and you want to separate all three. Then that time this chromatography technique is used. Chromatography is an important technique extensively used to separate mixtures into their components. Separate into their components. Again, things this important things again after removal, means if you will separate these compounds, that compound here in mixer it is said components, and then you will get the pure compounds. And also after that you can test the purity of compounds, whether it is pure or not. The name chromatography is based on the Greek word chroma for color. Actually this in Greek color is known by the word chroma. That's why chromatography, generally colored solution is separated, colored compound is separated by this method. Okay, it is based on this chromatography is based on the Greek word chroma for color, since the method was first used for the separation of colored substances formed in plants. In this technique, the mixture of substances is applied onto a stationary phase, which may be a solid or a liquid. Here 3 terms you have to understand in chromatography. First, in chromatography it is just like a burette shape. That instrument will be just like a burette shape, and in that first you have to fill it with a solid, generally silica gel. Okay, then that will be solid. That's why it is called a stationary phase. Okay, this may be stationary phase, may be solid or sometimes liquid also, but it will be stationary, means fixed. And second things, pure solvent. A pure solvent is also required. A pure solvent, or sometimes a mixture of solvents, or sometimes a gas is allowed to move slowly over the stationary phase. Means stationary phase, on that you will pass some suitable solvent or mixture of solvent, or sometimes liquids, mixture of liquids, or sometimes gas. Okay, this is passed slowly over the stationary phase. After that, what will you do? Third things, that is the components. The components of the mixtures get gradually separated. Actually, here that first you will take solid phase, a stationary phase. In that you will add, or you will put this that compounds, mixture of compounds, you will put on the solid phase, and after that solvent you have to pass. Okay, three things. First, stationary phase, that is also the stationary phase, fixed phase, and second, component, mixture of the compounds which you want to separate, you have to add, and third, after that, suitable solvent or mixture of solvent or mixture of liquids, sometimes gas, as per requirement, that is the pass through this compounds, and compounds are on solid phase, and these solvents are also called mobile phase because it will be moving. It will be moving. Then actually what will happen here, which principle will work, that I am telling, that if you will pass the suitable solvent, also called mobile phase, because it will move. Then here in that solvent, that mixture may dissolve. This compounds, suppose mixture of three compound was there, you want to separate, then when solvent you will pass, then this solvent, that any one mixture, any one compound of the mixture may dissolve more than other two. Means all will not dissolve in the same ratio. One may dissolve more, other may dissolve less, other further less. Then what will happen? That first compound which will dissolve more, it will pass through solvent. In solvent it will dissolve and it will pass through the solid phase, a stationary phase, and that in a stationary phase it will stick, and after that what will happen? Second will pass, second compound which was dissolved, then it will be with solvent only, and then it will go little far, and then it will be also absorbed by the solid phase. After some time, or after some distance, you will find that is also absorbed, and in the end last compound also, because it is very less soluble, it will go further, and again it will be absorbed in the stationary phase. Then you will say that different compounds, they may be different color, that will be separated. First compound will be separated, suppose it was the red. Now after some time, second compound will be adsorbed. Adsorption, one term is there, adsorption, AD, not AB, AD, adsorption, means upper layer it will stick, adsorbed, and in the end, suppose it red, after that green, and third was suppose blue, then you find that all are separated and there may be some gap between the two. Then later on, after that, these three compounds are separated from the solid phase. Okay, then this I have briefed you. Now just again you try to understand the components of the mixtures get gradually separated from one another. The moving phase is called the mobile phase. Based on the principle involved, chromatography is classified into different categories. Okay. Based on the principle involved, chromatography is classified into different categories. Okay, two important things I am telling you. First, adsorption chromatography, and second, partition chromatography. Means chromatography is the technique or method to separate the mixture of the compounds. Very simple way. Then now I am telling about the adsorption chromatography. Adsorption, actually what I told you, that is the main things, main principle. Okay. Then now just try to understand these two methods. First I told you adsorption chromatography. Adsorption chromatography is based on the fact that different compounds are adsorbed on an adsorbent to different degree. Adsorbent means solid phase is called adsorbent, which will absorb, or where this components will be absorbed, that is solid. That is the stationary phase is called, that is called adsorbent. Okay. adsorb, adsorb, bent, adsorbent. Then here adsorbent will adsorb in different degrees, means not in the same quantity. It will absorb three components, it will adsorb in 3 degrees, in 3 levels. Okay, not simultaneously, that can say different degrees, they will absorb in different degrees, that someone they will absorb more, other may be less, and for the third one will be further less, like that way. Means in percentage you can tell that 100% suppose you can tell mixture, then 60%, 40%, 60%, 30%, 10%, like that. They will not absorb this mobile phase will in that all will dissolve, but some may dissolve more, other may dissolve less, third may dissolve further less. Hence accordingly this adsorbent will, that is the stationary phase, will absorb. Then here I am telling you that this adsorption chromatography is based on the fact that different compounds are adsorbed on adsorbent to different degrees. Commonly used adsorbent are silica gel, solid phase, that is silica gel, sometimes alumina also, SiO2, that is silica gel, and Al2O3, that is the aluminum oxide or silicon oxide. When a mobile phase is allowed, just to understand, already I told you, now it will clarify. When a mobile phase is allowed to move over a stationary phase is called adsorbent. The compounds of the mixtures move by varying distance over the stationary phase. Now again I am telling you, following two methods are again there. Following two main types of chromatographic techniques based on the principle of different adsorptions are: first is column chromatography. Okay, this there are only the same principle, adsorption principle. There are two main types of chromatographic techniques based on the principle of different adsorption. First is the column chromatography. Column, COLUMN, column chromatography. and second is the thin layer chromatography. Question is asked. Then now I am telling you, first colon chromatography. Colon, I told you that this here chromatography, just like one you have seen burette type. It is just like a burette type, and in that in burette in the end, and the end that this will be there. Actually glass wool, just to stop the movement. In the burette you have seen that nozzle will be there, nozzle and stopper will be there. Like that way, there to stop the movement, that cotton wool is or glass wool is used, glass wool. Then glass wool is generally used at the end, just like near the stopper, stopcock. Okay. Then here what happens, I told you colon chromatography involves a separation of a mixture over a column of adsorbent stationary phase packed in a glass tube. Glass tube, just like you keep in mind that burette type, only this that thickness, diameter will be little more. Diameter will be more as per requirement. But like that type of tube only. One end will be opened, other end will be a stopcock will be there. Okay. And the end only that glass will be there. The column is fitted with a stopcock at its lower end. Now what will you do? Just to listen. That all things I told you, again I am telling you. The mixture adsorbed on the mixture adsorbed on adsorbent is placed on the top of the adsorbent column packed in a glass tube. Okay, here the mixture adsorbed on adsorbent is placed on the top of the adsorption column packed in a glass tube. An approximate eluent, another term also you can tell, eluent, ELUANT, eluent, that is a mobile phase. An appropriate eluent which is a liquid or a mixture of liquid is allowed to flow down the column slowly. Slowly and slowly you have to add. Depending upon the degree to which the compounds are adsorbed, all compounds will not adsorb in the same quantity. Some may adsorb more, other may absorb less. Then depending upon the degree to which the compounds are adsorbed, complete separation takes place. The most readily adsorbed substances are retained near the top and other come down to various distance in the column. This is called actually column chromatography. If suppose three color compounds were having three colors, then you will find that now these three compounds are adsorbed at a different distance in different color. This I have told you about the column chromatography. Now thin layer chromatography, other is thin layer chromatography. Okay, actually main principle is same, but minor changes there. Thin layer, here you will give the importance of layer. Thin layer chromatography. Thin layer chromatography, in short it is called TLC, TLC, thin layer chromatography, is another type of adsorption chromatography which involve separation of substances of a mixture over a thin layer of an adsorbent coated on a glass plate. Here glass plate you will take glass plate, on that adsorbent will be coated. Adsorbent will be coated on the glass plate, means a stationary phase. It is coated on glass plate. Okay, here this is a very, very important, and its thickness will be, coating thickness will be very less. A thin layer that is about 0.2 millimeter, 0.2 thickness, very less. A thin layer that is a 0.2 thick of an adsorbent, that adsorbent will be again silica gel or alumina, is spread over a glass plate of suitable size, maybe a small size, big size. On that plate, that it will be there, it will spread. Silica gel or alumina will be spread, and their coating will be, thickness will be less, 0.22, very less thickness. That will behave as a stationary phase. Now after that, what will you do? That the plate is known as, actually this plate is known as thin layer chromatography plate. This plate is known as thin layer chromatography plate or chroma plate, also called chroma plate. The solution of the mixture which you want to separate, maybe 2-3 compound may be mixed. Okay, then that mixture, that is the form of solution. The solution of the mixture to be separated is applied as a small spot about 2 centimeter above the end of the TLC plate. Suppose size may be big size, small size also, medium size, as per your requirement. Then that now mixture which you want to separate, that just 1 centimeter, that 2 centimeter, 2 centimeter from the end, one spot you have to put mixture to be separated. That mixture, just one spot you put, some drop you can put above the 2 centimeter above the end, 1 drop or 2 drops, just like one spot you put there above the 2 centimeter from the end. Now second work you have done, that mixture you have put, like it is also same way what I discussed. And now after that, more with mobile phase role will come, solvent role will come, eluent role will come. All are the same meaning, eluent, mobile phase or solvent, same things. Then now you have to dip this plate. Already you put the spot, mixture spot you have put. Now this you have to put in the, you can say near the this mobile phase. Mobile phase you have to put it. Then what will happen? That this mobile phase, means this liquid solvent, that will be absorbed by the this adsorbent, solid phase it will absorb, and it will move up. This in a beaker you can do this also. In beaker solvent is there, in that solvent, that plate you are dipping. Then from the down, from the end, last end, just you are dipping, so that while should this liquid or solvent should go up, slowly and slowly it will absorb, and again it will go up, and when it will go up, then it will pass through the spot, then again in a spot compound, different compounds are there, then it will absorb in a different degree. Then like that way it will be going up. Then which will dissolve more, they will go up, and this stationary phase will adsorb it. Again second liquid, again further it will go, there it will be adsorbed. Again third compound will, in the mixture third compound, again it will go further with this solvent up, and again that stationary phase will adsorb it, and like that way all three will be separated. Okay. Then this I have told you, the solution of the mixture to be separated is applied on a small spot about the 2 centimeter above one end of the TLC plate. The glass plate is then placed in a closed jar, maybe beaker also, closed jar containing the eluent. As the eluent rises up the plate, the components of the mixture move up along with the eluent to different distance depending on their degree of adsorption, and separation takes place. Okay, then how it will be separated, I told you. Now further, the relative adsorption, which component had absorbed more, how will you come to know? The relative adsorption of each component of the mixture is expressed in terms of its retardation factors, RF, capital R, small f, retardation factor, RF value, that is called RF value. Okay, what is the RF value? Relative this retardation factor RF. What is the RF? Question is asked. Retardation factor. Then this is actually relative adsorption of each component. Then RF is equal to, actually this is the distance moved by the substance from the baseline, that suppose it is the x, distance is x centimeter, maybe x, then distance moved by the substance from baseline divided by distance moved by the solvent from baseline, that is suppose y, suppose it is y centimeter, then obviously solvent will move more and this will move less. Then this distance moved by the substance from baseline means from the down one line mark will be there, from there it moved, then that distance you measure, suppose it is a x centimeter, and how much it moved solvent, suppose it is the y centimeter, then x divided by y, x upon y, that is called RF. The spots of color components, because this now separated, the spots of color components are visible. How will you see? Sometimes may be visible, sometimes may not be visible. Then if you want to see very clearly, then you have to see, you can say, in presence of some special liquid, special compound, special solvent. The spots of colored components are visible on TLC plate due to their original color. This is the one way you can see simply. The spots of the colorless compound, how will you see? Colorful you can see simply by seeing. The spots of, suppose some compounds was there, that is also separated, but it is colorless compound. The spots of colorless compounds which are invisible to the eye, but fluorescence one process is there, but fluoresces in UV rays. In UV light, if you will pass, then you can see colorless spot also you can see in presence of UV light, ultraviolet light, and this easily can be detected. After that, this also I told you, UV light will be, you have to pass in UV light, you can see. Then by the process of fluorescence you can tell. Then in ultraviolet light can be detected by putting the plate under UV light. UV light is there plate you can keep it, you can see. Another method is there to see. Another detection technique, how will you see? If it is not very clearly, then how will you see? One, I told you UV method, ultraviolet. In ultraviolet light you can see. In the front of UV light you can keep the plate, then you can see. Other method, another detection technique is to place the plate in a covered jar. In a jar you can cover it, containing a few crystal of iodine. There, in that you put some iodine in the jar. Iodine you put in the jar, and only in that jar you put the plate. Then what will happen? Then here spots of compounds which absorb iodine will show up brown spots. It will show brown spot. Okay, just because these spots separated a spot, it will absorb violet color. Iodine, after absorbing iodine, it will appear violet color. And then suppose three compounds were mixed, then now all three spots you will get violet, this brown color, not distant brown color. It will look like a brown color due to absorption of iodine. Due to the iodine vapor, now it will look brown. In this way you can see, okay, it will absorb iodine and will show up brown spots. Sometimes, and third thing I am telling you, sometimes an appropriate reagent may also be sprayed on the plate. Third things I am telling you, now some special liquid will be there that you can spray on the plate. For example, amino acids may be detected, suppose amino acids, many amino acids are there. Suppose amino acids are there as a compound, suppose amino acids separated, 3 amino acid, 3 compounds are separated. Then how will you, especially for amino acid I am talking about, that amino acids may be detected by spraying the plate with ninhydrin solution. On that plate, suppose mix as a compound, different type of amino acids are there. Then 3 amino acids were there and you have separated. Then now on that plate you put some ninhydrin solution. Then you can see it very clearly. Okay. Then that I have told you, and I will try to send some diagram of thin layer chromatography, and whatever I discussed I will try to send. Now I am going to tell these things, partition chromatography. What is this chromatography? Now just to understand. Partition chromatography is based on continuous differential partitioning of components of a mixture between stationary and mobile phases. Again you listen that partition chromatography is based on continuous differential differential partitioning of components of a mixture between stationary and mobile phase. Means some, the mobile phase will be moving, and this stationary, on a stationary phase it will be absorbed, and that is happening due to the mobile phases. Mobile phases means I am not talking about only one phase solvent, maybe 2-3 solvent, mixture of 3 solvent as a mobile phase. Then suppose one component may dissolve in one type of solvent, other will dissolve in other type of solvent, third will dissolve in third type of solvent. Okay. Then if a solvent will pass all three mixture, then all three compounds are 3, 4, 2, whatever be, that will be absorbed in their solvents and their spot will come. That is called differential partitioning of components of a mixture between stationary and mobile phases. Paper chromatography is the one example. Paper chromatography is a type of partition chromatography. This is again you understand paper chromatography. Paper chromatography means paper will be used here, special type of paper. Paper chromatography is a type of partition chromatography. In paper chromatography, a special quality, that is a special quality paper, not ordinary. In a paper chromatography means a special quality paper known as chromatography paper. A special type of paper is there, not ordinary, that is known as chromatography paper is used. Chromatography paper contains water trapped in it, which acts as a stationary phase. Here this chromatography paper, they will retain some water. Okay, chromatography paper retains water trapped inside, some water molecules will be there on that paper in it, okay, which acts as a stationary phase. This will act as a stationary phase. Water is absorbed. That is the purpose of a chromatographic paper, that it will absorb water molecules. That water molecules already it is trapped inside in that paper. That will function as a stationary phase. Now after that, a strip of chromatography, a piece of chromatography paper spotted at the base with the solution of the mixture is suspended in a suitable solvent or a mixture of solvent. Here any piece of the paper or strip of the chromatography paper is spotted at the base with the solution of the mixture which you want to separate. There is on the base it is there, you have a spotted you have put on near the base of the paper. That is now mixture is there. Mixture to be separated, now it is near the base of the paper. After that, third step, you put the mixture is there on the paper, that is the end, base down. You have dipped in the mixture of the compounds. Mixture of the compound, there you have little base you have dipped. Now some spot came, mixture absorbed on the paper. After that, third role will come for the mobile phase. Okay. Then a strip of chromatography paper spotted at the base with the solution of the mixture. After that, it is suspended in a suitable solvent. After that, this paper having a mixture of the compounds. Now we will dip in the solvent. Suitable solvent, you have to dip it. Suspended in a suitable solvent or a mixture of solvent. This solvent acts as a mobile phase. Its role has come. And after that, you know what will happen. The solvent rises up the paper by capillary action and flows over the spot. The paper selectively retains different components according to their different partition into phases. Okay, that mixture will be, water is also there in that paper, and this is also there, mobile phase is also there, or mixture of mobile phases means different solvents are there, hence all will be absorbed. Different mixture compounds of the mixture will be absorbed in different solvent, or some may dissolve in water, some may dissolve in solvent, a special type of solvent, because it may be mixture, then partition will be there. Okay. The paper selectively retains different components according to their differing partition in two phases, mobile phase as well as stationary phase. The paper strip so developed is known as chromatogram, because now you have separated all this paper has separated all mixtures, maybe 2, 3, 4 also. Then this is called chromatogram. This paper is called, or it is known as chromatogram. The spots of the separated color compounds are visible at different heights from the position of initial spot on the chromatogram. From down to up, you can see the spots. The spots of the separated colorless compounds may be absorbed. Already I told you, this colorless compounds may be absorbed under UV light or by the use of an appropriate spray reagent. Ninhydrin, I told you, ninhydrin. Like that way, you can see, spots can be seen, and further it can be separate. Already separated, you can see also. Later on, from that strip, again components are separated. They are cut pieces. They will cut in the different pieces according to, suppose 4 components were there, then all 4 will be cut in different parts, and after that again from that in suitable solvent they will dissolve. That compound will be dissolved in suitable solvent, and again, so because that is organic compound solvent, that will, if it slightly will heat, then organic solvent will evaporate, only that compound will remain. Like that way, you can say, you can separate the these things, mixture of the compounds, and that will be the pure compounds. Okay, then now I have discussed all the things, and today I am stopping only here, and next class I will discuss qualitative analysis of organic compounds. There are 2 types of analysis. One type of analysis, that is called qualitative analysis, because now you have seen that in any mixture what are there, how many you can say compounds are there. But how will you check it, test it? How will you test it? Then for that testing purpose, only for testing what are there, you have some mixture. In solution, some compounds are mixed, maybe 3, 4. Then how will you test that what are there? Or in any compound, other way also, in any compound, a compound may have so many, you can say, element present. As for example, organic compound is there, then what are the possibilities? That hydrocarbon is must, carbon and hydrogen will be there. Organic compound, if organic compound is there, then hydrogen and carbon hydrogen is must. Certainly it will be there. And after that, what are other things may be there? Then maybe oxygen, maybe nitrogen, maybe sulfur, maybe halogen, maybe phosphorus also. Total 10. Carbon, hydrogen, nitrogen, oxygen, sulfur, halogen, phosphorus. Then halogen, under halogen, 4 are there: fluorine, chlorine, bromine, iodine. Then total 10 are there. All 10 may be there. If organic compounds, you have taken organic compounds, you are doing analysis. Organic compounds analysis of given organic compound. In a lab, in higher classes, you have to analyze it. Sometimes in PUC level also, intermediate also, 12th standard. Maybe, but that will be very easy. Then you have to test it. What are the elements present in the given compound. Then at that time only we will test it. Quality test you are doing, and only quality, that how means how many elements are present. Only quality test you are doing. And this is the called quality, qualitative analysis. This is called quality you are checking, that's why name is given qualitative analysis. Okay. Now if you are knowing that, okay, this given organic compound has out of 10, 6 are present. It is not necessary what I told, all will be present in all compounds, not necessary. But carbon and hydrogen will be there, that is certain. And oxygen also may be there, nitrogen also may be there in general. But always sulfur may not be present, always phosphorus may not be present. Halogen may or may not be present. But you have to test for all. Then for that purpose, first you will do qualitative test. After that you will come to know, okay, 5 elements are there. 5 elements are there out of 10. Then how much they are there? Now you want to know quantitative. If carbon is there, then how much carbon is present? How much hydrogen is present? How much oxygen is present? How much chloride is present? How much sulfur is present? Then how much quantity now you want to know. That's why that is called quantitative test or quantitative analysis. Then there are 2 types of analysis: qualitative analysis and quantitative analysis. Then one by one I will discuss both. This is somewhat long. Then today it is not possible. That's why I will start next class, qualitative analysis of organic compounds. Okay, thank you.